Good morning, Professor.
Hey, good morning.
How are you?
Good, how are you?
I'm okay.
Tired of snow for sure. And ice.
Good morning, Professor.
Hey, good morning. I found it very strange that they canceled virtual classes last week. Didn't quite make sense to me. Still doesn't make sense to me because I just got the same information you did, but whatever. The one downside of losing that Thursday class was I actually had to delete one of our final exam review days. So whenever there is some sort of time in which we can't meet, back when I was teaching face to face, if there was a snow day, couldn't get the class, usually these exam review days end up being the first to go because of those are the most flexible days. So when we lose days like that, we do end up losing some of our review days, which I'm sure are very beneficial to you all. So kind of a shame there, but not too much we can do. In the minute that remains as well, does anyone have any questions about where we've been and where we're going?
Can you repeat what you said before about the review days?
Right. So whenever we lose a day, like we did this past Thursday, usually I have to modify the calendar in such a manner to make up for that lost day. And usually what I do is I eliminate one of our exam review days in order to compensate for that. So when we lose days like that, it takes away some of the review days I have scheduled to help you prepare for exams.
Okay, I see. Thank you.
Absolutely. Any other questions before we begin for today? Okay, well, if there's no further questions, we can get started. So, where have we been and where are we going? Well, in our last class, which is last Tuesday at this point, we spent a lot of time introducing important concepts within sensation and perception. We learned that sensation is a physical process that involves the detection of physical stimuli out there in the world, whereas perception is more of a psychological process that takes place in our minds. We then began. There's my voice again. In any case, we then began by taking our tour across the various different types of sensory experiences that human beings have, beginning with arguably our most important sense, the visual system. Within our discussion of the visual system, I also introduced 4 important functions of the visual system: light regulation, distance processing, color perception, as well as perceptual organization, courtesy of Gestalt theory. Now, because it's been a minute since we talked about Gestalt theory, I did want to refresh your memory on what this theory is all about. And according to Gestalt theory, people's minds have an automatic tendency to perceive whole images over their individual sensory parts. Okay, the human mind has an automatic tendency to perceive whole images over their individual sensory parts. The phrase that's most commonly associated with Gestalt theory is this idea that the whole is more than the sum of its parts. So one of the examples I gave was perceiving a car. So when you look at a car, right, you don't see a bunch of individual sensory parts first, like the nuts and bolts and rods and carbon fiber. Rather, you end up seeing a whole, meaningful car first, because your mind automatically puts all those pieces together to see that whole, meaningful image. But if a child who's never seen a car before in their life looks at a car for the very first time, they may not see a whole meaningful car. Instead, they see the individual sensory parts first, right? They may look at the tire and say, ball, that's a ball, okay? Now, we also talked about a lot of interesting abstract illusions associated with Gestalt theory, one of which is courtesy of what is known as the figure versus ground effect, which refers to the human mind's ability to perceive an object like a figure as distinct from its surroundings the ground, or the background context. And I was trying to iterate the importance of Gestalt theory or whole image processing by arguing that this type of processing is important because it allows us in our mind to impose a sense of order, structure, and predictability on our world. And if we didn't have this automatic ability to perceive whole images, our perception of the world would likely be very slow, confusing, fragmented, disjointed, and probably not make a whole lot of sense. And the figure verse ground effect is just yet another example of our mind's automatic tendency to put individual sensory pieces together to see different types of whole images. One really great example of this was the right-hand side illusion, where you can either see a young lady or an old lady. It depends on how your mind individually is putting those individual sensory parts together to see that respective whole image. Okay, that's Gestalt theory. Now, I know when I give you a lot of these abstract examples of Gestalt theory, even these visual illusions, it's kind of hard to appreciate the everyday implications of our mind's tendency to perceive whole images. So where I'm going next is I want to give you some applications of this. So one meaningful application is our mind's tendency to perceive whole images in otherwise meaningless cloud formations. Right? So when you look up in the clouds, especially maybe when you're a kid and your imagination was through the roof, you could see a bunch of meaningful objects and images in cloud formations, like animals or objects or houses or bears or even faces. In fact, the human mind has a pervasive tendency to see human faces in just about everything, even on the front of cars. Right? So the headlights of a car can be perceived as the eyes, the grille can kind of be perceived as the mouth, and so much so that many people even put fake eyelashes on their car's headlights to make them look even more human-like. Okay? Again, it's our mind's automatic way of trying to impose a sense of order, structure, and predictability on objects or images that otherwise lack that structure or order, in this case, cloud formations. Okay? However, it also turns out that our psychological states or emotions can have downstream consequences on the kinds of whole images that we see. Right? I want to draw your attention to this left side cloud formation here, which is actually an example of the 9/11 terrorist attack and the smoke clouds that were forming from the Twin Towers that were going down. And during this attack, clearly people were experiencing a lot of fear, a lot of anxiety and anger. And some people report it, and I have it circled here. You can kind of see an outline of a very angry looking face in the cloud formation. In fact, some very highly religious people even noted that it looks like the devil's face. And regardless whether the devil's face is actually represented in those cloud formations or not, it is a testament to the human mind's pervasive tendency to see whole, meaningful images in otherwise meaningless cloud formations. Okay? Any questions on that so far?
Yeah, I have a question.
Sure.
So basically the Gestalt theory in a nutshell is just like that one saying the sum of or the whole part is
the whole is more than the sum of its parts.
All right, okay? Thank you.
The human mind prioritizes whole image processing over the individual sensory pieces. In fact, as another easy example of this, I don't have it on the slides, but to me it's a good one, is believing in conspiracy theories. Or a few years ago when people would say Illuminati confirmed, right? Again, this is the human mind's tendency to perceive order and logic and whole meaningful ideas and otherwise meaningless connections. Okay?
Alrighty.
Absolutely. So this is a relatively lower stakes example of Gestalt theory, but now I want to give you a higher stakes application that even has some social implications to it. So Carell et al. In 2002 was very interested in investigating shooter bias incidents in police standoff situations with civilians. So what they did was they brought participants into the lab and they had them sit in front of a computer and had them play an experimental game where on the computer screen, they were shown images of black and white individuals like you see here on the slide, holding either a non-threatening object like a wallet or a threatening object like a gun. And the participants were asked to make a shoot or no shoot decision extremely quickly to kind of mirror the conditions that police officers face on an everyday basis when they're faced with these kinds of high stakes situations. Now, from this paradigm, Carell et al. Found three important findings. The first finding was that we did find some evidence for shooter bias. It turns out participants were more inclined to make a shoot decision for the African American target, irrespective of what object they were holding. Second, we did find that prejudice can certainly ramp up these shooter bias effects, which makes a whole lot of sense. But the last finding was perhaps the most fascinating. We found that this shooter bias effect occurs for both Black and white participants making the shoot or no shoot decisions. And the reason that finding is so curious is because presumably African American participants don't harbor any explicit prejudice or racism towards members of their own group, which is why the prevailing explanation was actually more closely aligned with stereotypes. Because what everybody knows, regardless if they're Black or they're white, Hispanic or Latino or Asian, are stereotypes linking certain groups of people with positive and negative qualities. In this case, linking African Americans with deviance, hostility, crime, and aggression, right? Now, the implications of this are such that, although prejudice can certainly ramp up these findings and make them a whole lot worse, which makes a whole lot of sense, prejudice is not a necessary factor to see these shooter bias type incidents. Just knowing the content of stereotypes, whether you endorse them or not, is enough to breed these types of shooter bias effects, suggesting that the implications of shooter bias are far more wide-reaching than we originally thought, which is also a little bit scary. Any comments or insights on that before I talk about the connections between this and Gestalt theory? Right? Is that fascinating? Is that insightful, given a lot of the important and timely things we've been hearing in the news over the past few months?
It's very fascinating.
I would say that, like, to me, it's not that surprising because it's like, I feel like it's more like a psychological thing, because in the media, African Americans are portrayed as all those things anyway. So even like as a someone that is African American, like you do kind of have those it's like kind of instilled in everyone's mind. So to me, like that wasn't really that surprising because of that.
Right, certainly. I mean, you could wake up in the morning and wonder, is today going to be the day where something bad potentially happens to me if I'm pulled over, if I have an altercation with the police? You know, who knows? You know, there's a lot of scary perceptions associated with that. Yeah. Very real life. Yep.
Exactly.
Absolutely. Any other thoughts on this as a finding before we make connections between this and Gestalt theory? Well, just to add a little bit on top of this, this study has been replicated in a number of ways. One way in which this study has been replicated is by having police officers actually serve as the participants. So instead of having everyday citizens make the shoot or no shoot decisions, police officers were then participants in this study, and we saw the exact same thing. Additionally, there's also been replications where researchers have varied the context behind the individual. So in some conditions, there would be like a really run-down environment behind the individual with broken windows and overturned cars, you know, kind of a chaotic environment. And then in other conditions, there was a very nice, well-to-do, like upper class area behind the individual. And we find that during the conditions in which the context was kind of like in a run-down, broken-down environment, participants were also more inclined to make the shoot decision on that target, especially if they're African American, which is very fascinating. Any other thoughts on that? Okay, so how does this relate to Gestalt theory, right? The human mind's ability to perceive whole images over individual sensory pieces. So the idea here is that when participants are viewing these kinds of images, they're not just paying attention to the individual sensory pieces, or in this case, the gun. If all participants were doing was paying attention to the gun, the individual sensory piece, we likely wouldn't see quite as bad shooter bias effects as we see today. But that's not quite what's happening here. Participants aren't just focusing on the gun. They're looking at the person holding the gun, as well as the background context behind the individual. In other words, they're processing the whole image, And as a consequence of processing the whole image automatically, it could trigger stereotypes in participants' minds, in this case linking African Americans with deviance, hostility, and crime, that could cause people to misperceive a non-threatening object like a wallet as a threatening object like a gun. And that's how these kinds of effects happen. Okay. Any other lingering thoughts on that before we move on? Okay, well, we're going to revisit the Carell et al. 2002 study when we eventually get to our topic on stereotyping, prejudice, and discrimination, so keep all these findings in the back of your head. But in any case, I actually have one more example for you all, which is also a very short little activity that I need one person's help with. And it's not going to involve you to do a lot. You just have to read a sentence on the screen. So who would like to help me on this?
I got you.
All right, fantastic. So what's going to happen is when I change the slide, you're going to see a triangle. And in that triangle is a sentence. And I want you to read that sentence as fast as you can as soon as you see it. Does that make sense?
Hold on, let me get my glasses.
Okay. So let me know when you're ready.
All right, I'm back.
All right, here it goes.
I love Paris in the springtime.
All right. Well, it turns out you actually read it wrong. It's I love Paris in the springtime, right? So you omitted the extra the, okay? But don't feel too bad because it turns out that most people actually make this mistake. And the reason we're making this mistake goes back to Gestalt theory, right? The human mind's automatic tendency to perceive whole images. When people are reading that sentence, they're typically not painstakingly reading every single individual word or sensory piece. Rather, when we read, we take the gist of the whole sentence in order to extract meaning from it. In fact, this is a part of the reason why speed readers can read as fast as they can. Because yet again, speed readers aren't painstakingly reading every single individual word. Rather, they're very quickly extracting the meaning or the gist of the whole sentence and quickly going from sentence to sentence to sentence, extracting meaning from it. Okay. But who are the kinds of people then that don't make this mistake and pay attention to every single individual word when they're reading? Well, those kinds of people are typically engaging in what is known as bottom-up processing. Bottom-up processing refers to the analytic processing of individual sensory pieces, right? The analytic processing of individual sensory pieces, okay? Bottom-up processing got its name from this idea that when people are processing their world, they're beginning from the bottom up, right? With this very piecemeal analytic analysis of all the individual sensory pieces and putting those sensory pieces together in order to come to some sort of meaningful conclusion, okay? The kinds of people that are doing this in the prior example are the individuals that are reading every single individual word in that Paris and springtime sentence. And the demographic of people that is typically doing this is usually early readers, right? We're talking about maybe children who are just starting to learn how to read. Because for children who are just starting to learn how to read, they often have to painstakingly read every single individual word and then combine those words in the sentences while keeping in mind the rules of grammar and syntax in order to extract meaning from it. So they usually don't make that mistake. In contrast, adult populations like you and I usually do make the mistake because we're engaging in a different type of processing. We're engaging in top-down processing. And top-down processing is a holistic processing of stimuli based on prior knowledge. Okay, a holistic processing of stimuli based on prior knowledge. Okay. Now, I want to draw your attention to one really important word in this definition, and that's holistic. Holistic has very strong relations to whole image processing, right? Holistic, whole image processing. Top-down processing is the kind of processing that Gestalt theory is proposing that people are engaging in. So I want you to link Gestalt theory and top-down processing in your mind together because in some ways they're one and the same. This is the kind of processing that people are engaging in courtesy of Gestalt theory. But let me give you a different example now. Let's take a chess example, like what you see here is the early stages of a chess game where it's black's turn to play. And when chess novices look at this board, they're engaging in bottom-up processing. Because they don't have a lot of prior knowledge about chess strategies and chess formations, they're often beginning from the bottom up. They're beginning with an analytic processing of all these individual pieces on the chessboard. And after this analytic processing of all the individual pieces on the board, they come to some sort of tempting conclusion that the best play is for this black pawn to take this white pawn on f4 because it seems like a free pawn with no negative consequences. However, chess experts know that this is a trap because chess experts are engaging in top-down processing. When chess experts look at this board, they first see a whole, meaningful formation. They see the king's gambit opening, where if black takes this white pawn here on f4, all white has to do is move this pawn on d2 up one square, and they can instantly retake with the bishop and gain center control. And as anyone who's ever studied a little bit of chess theory can tell you, gaining center control is extremely important in a chess game that will set you up for a good middle game and ultimately an end game. Okay? Any questions on the difference between bottom-up and top-down processing? Just want to make sure that's clear. Okay. So we spent a lot of time at this point talking about the visual system and information processing and color processing and so forth. But now we need to begin talking about another sensory experience, hearing, our auditory system. Now, as I said last Tuesday, across every single sensory experience that we have, the general process from sensation to perception is exactly the same. Across every single sensory experience we have, it begins with a physical stimulus that is detected. In the case of our visual system, that physical stimulus was light waves. In the case of our auditory system, that physical stimulus are sound waves. Those light waves and sound waves are then detected by sensory organs on our body. Of course, with our visual system, the sensory organs are our eyes, and with our auditory system, the sensory organs are our ears. And presiding in our eyes and ears, respectively, are sensory receptors that begin the transduction process of converting those light waves and sound waves into neural impulses. Remember, our brain does not have any meaningful way to interpret light waves or sound waves, respectively. They have to be converted into a language that our brain can understand. Neural impulses. Seeing and hearing isn't happening out there in the world like you think it is. It's happening in your mind. Okay? After those neural impulses then make their way into our brain, you then begin the ultimate perceptual experience, in this case, of hearing. Okay? That is the general process from sensation to perception. So where we're going next is I want to talk about the different components of the ear involved in this process, starting with the outer ear. So the first part of your outer ear is the pinna, right? The pinna is this flimsy cartilage structure that you can touch with your hands that many people also decide to decorate by piercing their ear, right? Or their pinna. Now, as a fun fact, the pinna is actually shaped intentionally the way it is because it helps funnel sound waves into your ear canal. In fact, a part of the reason why dogs can hear as well as they can is because oftentimes dogs' ears are in a funnel shape and they're large to help funnel sound waves into their ear. But that's not the only reason why dogs can hear so well. In fact, perhaps more importantly, we also know that the sensory receptors inside dogs' ears are much more sensitive to sound waves than what we see in human populations. But whatever the case may be, the pinna certainly plays one role in that. So after the pinna funnels those sound waves, they then enter into your ear canal. The ear canal is the part of your ear that you stick all those Q-tips into. But yet again, as another fun fact, you're not supposed to do that. In fact, if you go to the dollar store and you buy yourself a pack of Q-tips and you look on the back of the box, you'll see a warning label. And that warning label is telling you to not stick those things in your ear canal because the company is worried that you're either going to damage your ear canal or bust your eardrum. And then they'll get sued and get in a lot of trouble. In fact, if you don't believe me, go to the dollar store, buy a pack, and you'll even sometimes see pictures on the back of the box where the company is telling you what you should be using these Q-tips for instead. Like maybe putting alcohol on the tip and cleaning out a wound, or maybe using it to clean your computer's keyboard or whatever. But you're not officially supposed to stick those things in your ear like that. Any thoughts on that or insights?
Yeah, I just have a random story.
Yeah.
One time at track practice, my friend put a sunflower seed in his ear canal, and it almost got stuck, so I had to take it out with tweezers. But yeah, bottom line, never put anything in there.
Yeah, that sounds like a really bad idea. Like almost as bad as what do you call it? Eating Tide Pods? Not a good idea.
Oh yeah, for sure.
Yes. Any other thoughts on that?
Is there any way to like naturally clean your ears without using Q-tips?
So one of the safer ways, and often doctors often recommend this as well when you have an ear infection, is to use the liquid inside your ear, right? The ear drops that can like unclog all the earwax and it naturally kind of drips out when you hold your ear down. But the problem with that is that's oftentimes not very convenient for people. So it's much easier to just take a Q-tip and start cleaning out your ears instead. But not only can that damage your ear potentially, but could also push the earwax deeper into your ear canal, which could make it worse. And that's part of the reason why people often rely on these things instead is because they're convenient. Well, in any case, when those sound waves enter into your ear canal, they eventually bang, metaphorically speaking, on your eardrum. Okay. Now, to give you some applications of the eardrum, and as I was kind of alluding to before, if you've ever had an ear infection, the reason why you can't hear all that well is because usually there's a lot of fluid built up in your ear canal, which prevents those sound waves from banging, metaphorically speaking, on your eardrum at the same intensity that they should be able to. Same principle behind having swimmer's ear, which is often stemming from a lot of bacteria-laden water getting built up in your ear canal, again, preventing those sound waves from banging on that eardrum and causing the vibrations to funnel their way into the middle part of your ear. The middle part of your ear contains 3 ossicles, okay? The hammer, the anvil, and the stirrup. Now, for the purposes of your second exam, I'm not so much interested in you remembering the specific functions of the hammer, the anvil, and the stirrup. Rather, I just want you to generally know that when the sound waves hit these ossicles, they vibrate, and they continue to pass those vibrations into the inner part of your ear. Now, there are a lot of structures in your inner ear that I do want you to remember for your second exam, because some of these structures play a role in the transduction process. The first important structure of your inner ear is the cochlea. The cochlea, as I'm kind of circling here, is this snail shell-like structure that contains the sensory receptors in your ear that begin the transduction process of converting sound waves into neural impulses. The sensory receptors that are contained in your cochlea are known as hair cells. And the hair cells are the critical structures that I want you to remember that begin the transduction process. In fact, to draw some analogies here, you may remember that in the visual system, the sensory receptors that began the transduction process were the rods and the cones. Whereas in the auditory system, the sensory receptors that began the transduction process are the hair cells vibrating from those sound waves. Okay, remember them for your second exam. Okay, now after those hair cells vibrate and convert the sound waves into neural impulses, the neural impulses are then passed down the auditory nerve. Okay. The auditory nerve is essentially the bridge in between your ear and your brain. And when the auditory nerve passes those neural impulses into your brain, they first hit what structure of your brain that's responsible for processing all sensory experiences? Who remembers?
Is it the thalamus?
The thalamus, exactly. All sensory experiences are first processed by the thalamus, which is a part of your limbic system. After the thalamus processes it, it then relays it to specific parts of your brain that handle hearing-related information. Who remembers the lobe of your brain that's responsible for hearing? To jog your memory, you may remember that with the visual system, the lobe of your brain responsible for seeing is the occipital lobe. So what would be the auditory system's equivalent? There's 3 potential options left. It's not the occipital lobe.
Is it frontal?
Say that again, sorry.
Is it the frontal?
Not quite the frontal. There's still a lobe that's more important for hearing. You're in the domain of what it could be, though. So it's not the occipital lobe. It's not the frontal lobe. It has to be the temporal lobe, exactly. And presiding in the temporal lobe is the primary auditory cortex, which then ultimately gives you the perceptual experience of hearing. That's the general process from sensation to perception. Any questions on that process and the components of it involved?
What's the function of hair cells again?
Yes, the hair cells are exceptionally important. Okay, they are the sensory receptors that convert those sound waves into neural impulses when they vibrate. Okay, they begin the transduction process. Does that make sense?
Yes, thank you.
They're essentially equivalent to the rods and cones of your visual system. Okay. Yes.
Yeah, sorry. Could you just describe the cochlea again?
Sure. The cochlea is this snail shell looking structure that I'm kind of circling here that contains the sensory receptors or the hair cells that begin the transduction process. So to give you an analogy with the visual system, it's somewhat equivalent to the retina in the back of your eye, because the retina contains the rods and the cones in the same way that the cochlea contains the hair cells. Does that make sense?
Yeah.
Great question. Okay, so just as we did with the visual system when we talked about the factors that could cause blindness, I also want to talk a little bit about here the factors that can cause deafness. Now, just with the visual system, and as I think you can see here, there's a lot of moving parts to our auditory system, right? And if any one of these delicate parts gets damaged or interfered with, it can significantly alter your ability to hear. In fact, we do have a lot of evidence for what is known as sensorineural hearing loss. This is hearing loss that's caused by damage to your cochlea hair cells or the auditory nerve itself. Okay, so starting with the auditory nerve, you may remember that the auditory nerve is essentially the bridge in between your ear and your brain that the neural impulses pass through. But if this auditory nerve gets damaged to the point where the neural impulses are no longer going into your brain, you do not hear. It's as simple as that. Remember, hearing isn't happening out there in the world like you think it is. Hearing is happening in your mind. Okay? Likewise, if there's damage to your hair cells, that can also cause hearing loss because your hair cells begin the transduction process of converting sound waves into neural impulses. And your brain doesn't have any meaningful way to interpret sound waves in and of its own right. So if the hair cells don't do their job, you also do not hear. It doesn't happen, right? They have to be converted into neural impulses and sent to your brain in order for the perception of hearing to occur, okay? Now, as far as we know in research, if you have damage to your hair cells, maybe perhaps because there's a lot of loud music you're playing in your ear, or, loud environment for a persistently long period of time, those hair cells don't repair themselves and they don't regenerate. In other words, once you lose your hearing ability, it's gone. It's not coming back. It's permanent. And to drive that point home further, we find that 1 in 5 teenagers has hearing loss, which is really problematic and concerning because when you're in your teens and your 20s, that is when your hearing ability should be at its best. But despite this, we see that 1 in 5 teenagers has hearing ability at the level of someone, say, in their 60s or 70s, which is exceptionally concerning. And as you can imagine, one of the leading culprits associated with this are earbuds, like playing loud music in your ears. Because earbuds essentially provide the perfect storm for hearing loss, because there's only one place for all those sound waves to go, directly into your ear canal and permanently damaging your hair cells. Okay. In fact, to draw some relations with what we talked about last Tuesday with the just noticeable difference, you may remember that example I gave when you're in your car, you're listening to music at the level of 5, but then you enter into an area along your commute that's really noisy, right? Construction noise at the level of a 7. You can't hear your music all that well, so you crank it up to 11 to hear it comfortably. But that could be permanently damaging your hair cells. In fact, relatedly, we're all of us being at home doing schoolwork and whatnot, and our family's home. There's your mom, your dad, your brother, your sister, and who else? Everyone's causing noise in the household. So when you're trying to get homework done, it's very tempting to put earbuds in your ears and crank up the volume to tune out all of that outside distraction. And although that may work to some extent, you may be permanently damaging your baby hair cells inside of your ear. Okay, so the general recommendation here is that if you find yourself tempted to crank up the volume of your headphones, just get yourself a pair of noise-canceling headphones that allow you to listen to your music comfortably without the temptation of trying to tune out outside noise by cranking up the volume. Okay, that's the idea. Any thoughts on that before I continue?
This is only but what about you ever just get random ringing in your ears? Or I know for me, it's always when I'm about to go to bed. It's like a high-pitched ringing in my ear.
Right. Yeah, I believe that's called tendinitis, I believe. And I don't have a whole lot of research on that in the back of my head, but I know that can sometimes happen spontaneously. It may not necessarily always be an indicator of hearing loss. Sometimes it could just be a result, in some cases, of your sensory systems misfiring. But I do know there's some other evidence to suggest if you do hear ringing in your ears after you hear something really loud, or maybe after you went to a concert, that could be potentially one indicator of potential hearing damage. So in other words, tendinitis is not necessarily always associated with hearing loss, especially if it's occurring just randomly in a quiet environment, but it could be if it precedes you being in a very loud environment like we're about to talk about next. Okay?
Okay, cool.
So earbuds aren't the only reason why you could potentially have hearing loss. In fact, I have a very convenient chart for you here where it starts with about 8 hours of vehicle traffic. We find that if you're exposed to 8 hours of vehicle traffic at a time, nonstop, that could potentially cause permanent hearing damage. And you may be wondering, right, when am I ever going to be exposed to 8 hours of vehicle traffic at a time? Well, let me give you a personal story. So when I got accepted to my PhD program at Ohio University, I was still living in Jersey at the time, and I was a poor student, and I had an old beater car where the air conditioning didn't work, and I was traveling in the summer. And the distance between New Jersey and Ohio driving is about 8 hours. And I did the entire trip with the windows down. And that was not a good idea because as anyone who's ever driven with the windows down on a highway can tell you, it's extremely noisy, right? There's a lot of wind noise coming in. There's vehicle traffic noise coming in. And I did that for about 8 hours. And as a consequence of doing that, my hearing ability in my left ear is actually markedly worse than my hearing ability in my right ear because my left ear was closer to the window. And in fact, when I was teaching face-to-face before COVID, there's times where students on the left-hand side of the classroom would have to repeat themselves a few times because I wouldn't be able to hear them quite as well as the students on the right-hand side of the classroom. So again, the general recommendation here is don't be like me. And if you're going on a long distance road trip, keep your windows up for the vast majority of it. It'll also be better for your gas mileage. Okay. Next up, we have just 15 minutes of being at a rock concert can cause permanent hearing damage. And the last I checked, rock concerts typically last for longer than 15 minutes. So when you sign yourself up to go to a concert, you're also signing yourself up for permanent hearing damage. Okay. So many people often say, especially people who are frequent concert goers, will very adamantly and confidently say, hold on a second, I go to concerts all the time and I don't feel like my hearing ability is any worse than the average individual. And maybe it is right now. Because when you're in your teens and your 20s, you're falling from such an incredibly high altitude when it comes to your hearing ability that you may not even notice the small incremental drops in your hearing that may occur from going to concerts. But if you keep going to concerts week after week, month after month, year after year, it could eventually get to the point where you're in your 50s or your 60s and you do need a hearing aid in order to hear properly. So again, the general recommendation is if you're a frequent concert goer, wear some sort of hearing protection. Okay. Any other questions on that? Well, if I haven't spooked you enough, there are some other causes of hearing loss unrelated to loud noise in the environment. Okay. We know that some hearing loss is genetic. So if your grandmother, your grandfather, your mother, your father has some evidence of accelerated hearing loss, that could potentially put you at risk. And we also know as people get naturally older, right, the hair cells inside their ears become just less sensitive to sound waves and you hear less well. And even though many older adults may not need hearing aids, it's because they likely took very good care of their ears when they're younger. So when they got into their old age, they can still hear perfectly fine. So the moral of the story here, protect your baby hair cells because once you lose your hearing, it's gone and it's not coming back. Any lingering questions? Okay. So we have the ability to see, we have the ability to hear, we also have the ability to smell. Olfaction is the sensory perception of smell. Now, as I've stated across every single sensory experience we've talked about, the general process from sensation to perception is exactly the same. Across every single sensory experience, it begins with a physical stimulus being detected. The physical stimulus of our visual system was what?
Light.
Light waves, right. The physical stimulus of our auditory system was what?
Sound.
Sound waves, right. The physical stimulus associated with olfaction are odorants, okay? Those odorants are then detected by sensory organs on your body, in this case, your nose. And inside your nose is a structure that contains the sensory receptors that begin the transduction process. That structure that contains the sensory receptors is known as the olfactory bulb. And presiding in the olfactory bulb are the sensory receptors that begin the transduction process. They are called olfactory receptors, okay? Olfactory receptors. The olfactory receptors are analogous to the rods and cones of your visual system, as well as the hair cells of your auditory system. They convert those odorants into neural impulses. And after those odorants are converted into neural impulses, they then pass down the auditory nerve. The olfactory nerve. The olfactory nerve is the bridge in between your nose and your brain. And it passes those neural impulses into your brain, and it first hits what structure of the brain that processes sensory experiences?
Thalamus.
That was actually a trick question. So I know I mentioned it very briefly in our lecture on biology and the mind. Smell is the only sensation that bypasses the thalamus and goes directly to the part of the brain that's responsible for processing smell-related information, and that's the olfactory cortex. So again, smell is the only exception to that otherwise general rule that the thalamus processes all sensory experiences. Okay. But with that said, that is the general process from sensation to perception. Okay. Now, with that said, I did also want to talk about some really fascinating nature v nurture interactions when it comes to our smell preferences. Starting first on the nurture side of the debate, there are a lot of learned smell associations that we learn from our environment. One good example of this is smell aversions. So let's say you went out all night partying with your friends and you got a little bit intoxicated. So much so that maybe that alcohol made you nauseous and maybe even led you to vomit. Now, the next day, you probably wake up a little bit hungover and you make your way to the kitchen. And then let's say you smell that same smell of alcohol that got you sick the night before. And just smelling that same smell of alcohol is enough to bring back all of those old nauseous feelings and may even lead you to vomit. You've developed a learned smell aversion to that alcohol that may persist for a few hours or a few days or maybe even a few weeks, depending on the severity of how sick it made you. That's one example. Another good example of this, especially in infancy, is that we also find that babies learn to prefer the smell of their mothers. In fact, many pediatricians often recommend that if new parents, especially new mothers, are trying to build attachments and bonds and security with a newborn child, is to wear similar smelling perfume when you're around them. So the baby will learn to associate the smell of that perfume with the safety and security of, say, their mother. In fact, that was actually the advice that my mother got when she had me. And to this day, honest here, my mom still wears very similar smelling perfume. So as an adult, whenever I go to hug my mother, I get all those nostalgic feelings of being at home as a kid with my mom. Okay. Speaking of nostalgia, right? People have a lot of learned nostalgic associations with particular objects in their environment. Right? Maybe when you were a kid, your parents always used to cook fresh bread in the morning, to such an extent that now as an adult, when you walk past a bakery and you smell fresh bread coming from that bakery, it's enough to bring back all of those old nostalgic memories of when you were a child back at home with your parents. Those are all learned smell associations courtesy of the environment. But nature plays a role too. We also have a lot of smell preferences that are hardwired into our brain at birth. Okay. One example in the realm of attraction and relationships is we actually have some evidence that men can actually smell women who are ovulating. And I know that sounds a little weird, but allow me to explain. So we find that when women are ovulating, when they're at their period of their cycle, when they're most fertile, they actually emit more pheromone emissions that men, whether they know it or not, are picking up on. And those pheromone emissions increase their testosterone levels. And we know that testosterone may also have downstream consequences on sex drive, with the net result of this being that men report greater attractiveness to women who are ovulating than women who are not ovulating. Well, what's happening with women? Well, when women are ovulating, we also see spikes in their estrogen. And estrogen also has downstream consequences on sex drive. So what's happening here is that nature is trying to bring two people together when the chance of conception is most likely to occur. It's a mating strategy. And we're not the only animals to do this. There's a lot of other non-human animals that use this type of thing as a mating strategy as well. So the implications for your everyday life are such that if you're in a relationship with somebody and you find that there's a certain time of the month where you just can't seem to keep your hands off of one another, this is likely one of the reasons why. Nature is trying to bring you two together when you're most likely to conceive. That's the idea. Any questions on that? Well, related to this, we also find that when women are pregnant, their ability to smell is enhanced. In fact, as anyone who's ever been around a woman who's pregnant, or maybe you've been pregnant yourself, you may notice that you not only have superhuman smelling ability, but you're also becoming disgusted by things that never made you disgusted before. And the reason for that is that when women are pregnant, their immune systems are slightly compromised. And nature, noticing this, enhances their smell capabilities and makes them more sensitive to potentially dangerous pathogens that could potentially make them ill or their unborn baby ill and kill them. So it is a survival function. So we see even more evidence here that nature has designed our minds and bodies to promote survival and reproduction above all else. In fact, this is the same general idea behind why women often have nesting patterns or nesting motivations, which refers to these motivations to clean, tidy up, and get rid of germs. Okay. Again, same reason. When women are pregnant, their immune systems are slightly compromised. Nature, noticing this, enhances these nesting motivations to encourage women to clean, tidy up, and get rid of dangerous pathogens that could potentially make them or their unborn baby ill and kill them. Again, more survival and reproduction functions. Okay. Any questions on any of that? I thought you'd find some of those applications kind of interesting. Well, at the very least, it's kind of like the more you know, right? More facts about life, I guess.
They're true, though. I think they're true.
Yeah, I mean, we have a lot of evidence for this. And we also have a lot of evidence on the biological level about why it happens. It's often related to that immune system. Any other thoughts before we move forward? Okay, so we have the ability to see. We have the ability to hear. We have the ability to smell. We also have the ability to feel a whole lot of pain. Now, yet again, across every single sensory experience we talk about, the general process from sensation to perception is exactly the same. Across every single sensory experience, there are sensory receptors that convert physical stimuli into neural impulses. In the visual system, those sensory receptors are the rods and cones. In the auditory system, those sensory receptors are the hair cells. In the olfactory system, those sensory receptors are olfactory receptors. With touch and pain sensations, they're called nociceptors. The sensory receptors in your muscles, skin, and organs that convert physical pain signals into neural impulses. Now, you all already know the general process involving pain. When you stub your toe on that chair, you have sensory receptors in your feet which convert those physical pain signals into neural impulses that then travel up your leg, up your spinal cord, into your brain for further processing. You then feel pain, you say ow, then the signals travel back down your brain, down your spinal cord, to your hand to now help you meaningfully respond to your environment. You already know the general process of pain from what we talked about in exam 1's content period. Okay? But it's still a little bit more nuanced than that. In fact, I left out this next fact because I want to talk about it here. I thought it made more sense. So we find that when pain signals are traveling up to your brain, they're traveling across one of two pain nerve fibers. Sharp and intense pain, say from cutting your finger with a knife, are traveling across fast pain nerve fibers. And they're called fast pain nerve fibers because the signals are traveling relatively quickly up to your brain. And they're traveling as fast as they are because fast pain nerve fibers are very heavily myelinated. In fact, you may remember the myelin sheath from our lecture in biology in the mind. The function of the myelin sheath is to encourage fast and quick and efficient communication of neurotransmitters. Okay? And it's actually really quite functional for sharp and intense pain to travel quickly to your brain, because remember, something immediately threatening just happened to you, right? Maybe you cut your finger with a knife. You want to feel pain almost instantly to better react to your environment, okay? In contrast, dull and achy pain, say from stubbing your toe on a chair, instead are traveling across slow pain nerve fibers that travel relatively more slowly up to your brain, because these slow pain nerve fibers are not very heavily myelinated. So again, they travel relatively slowly. But keep in mind that it's actually relatively functional for these neural impulses to travel slowly, because what it's doing is it's producing a dull ache as they slowly sequentially get to your brain. And that dull ache is encouraging you to protect a part of your body that just recently got injured, right? If you felt pain and then it instantly went away after a few seconds, you may not be inclined to continue protecting that part of your body. But because you have that slow, gradual ache that lingers, that encourages you to keep yourself and safe from further injury, especially in that part of your body. Okay? Any questions on those two types of pain nerve fibers? Okay. Now, many people in their everyday lives are often very quick to say that they wish they never felt any pain at all. But I'm here to make the case to you today that you really don't want that reality. And you especially don't want that reality for short-term pain. So let's consider that hypothetical. You don't have the ability to feel pain at all. So you're walking down the street and you step on a nail, but because you don't feel pain, you just keep walking casually to your destination and you're bleeding out from your foot. Certainly not very desirable. You want to feel pain, especially short-term pain, because that short-term pain is telling you that something bad just happened on your body and you need to protect yourself or go to the doctor. Okay. Rather, the kind of pain that people often really refer to that they wish they never felt anymore is chronic pain, especially chronic pain that is unable to be treated by modern medicine, right? Maybe we're talking about chronic shoulder pain or back pain that the best doctors can do maybe is give you pain relievers to improve your quality of life. Okay, these are certainly instances where the experience of pain can be largely dysfunctional, because pain is telling you that there's something wrong on a part of your body that you cannot fix. So it's not very useful now. It's just causing you distress. This is usually the kind of pain that people mean and refer to when they say they wish they never felt pain at all. Okay. But in any case, there's been a lot of really important theories of pain that have taken place throughout the course of psychology's history. One of the most important is gate control theory. And according to gate control theory, there is a neurological gate in your spinal cord that may open or close that could influence whether those pain signals make it to your brain, right? So if that neurological gate is metaphorically closed and those pain signals don't pass through your spinal cord and get to your brain, you do not feel pain. The implications of gate control theory are such that pain is more of a psychological experience than it is a physical one. Pain isn't happening on your finger like you think it is. Pain happens in your mind. So if there is something preventing those pain signals from making it to your brain, you don't feel pain. It's as simple as that. Now, there's a lot of examples and applications or factors that could cause that neurological gate to close, relatively speaking. One of these factors you've already heard of before, endorphins, right? You may remember that endorphins are that neurotransmitter that's involved in pain reduction. Right? When endorphins are released in the brain, they close that neurological gate in your spinal cord that can prevent those pain signals from making their way to your brain. And that's why you feel less pain. Relatedly, we also know that optimism can play a role in not only releasing endorphins in the brain, but also helping individuals who are sick or maybe recovering from really serious illnesses in the hospital get better quicker. Because to the extent to which people who are recovering from a major illness or problem are optimistic about their chances of recovery, there are endorphins that are released in their brain, which not only reduce their experience of pain, but facilitate the recovery, suggesting that the recovery process for people recovering from really serious illnesses is not just a medicinal one, it's also a psychological one that takes place in your mind. So for the people that are better able to manage their expectations of how well they're going to get and their likelihood of recovery, they also have a higher chance of getting better quicker and have a better quality of life, okay? Which I think is pretty cool. Any questions on that so far? Okay. So the underlying message here, and I'm reiterating this again because it's exceptionally important for understanding not just pain, but all of the sensory experiences we've talked about so far, is that pain is psychological. But not only is pain psychological, but your ability to see is psychological. Your ability to hear is psychological. Your ability to smell is psychological. Seeing and hearing and tasting and touching isn't happening out there in the world like you think it is. It's happening in your mind. And to drive that point home as far as I can take it, here's a few other examples with pain. Take epidurals. When women are giving birth, right, they're in labor, they may decide to get an epidural where there's a small injection in the lower part of their spinal cord which closes that neurological gate, preventing those pain signals from below the waist from making their way to the brain. And as we just talked about, if those pain signals can't get to the brain, you do not feel pain, right? Which is why for women who've received epidurals, maybe even a few hours after they've given birth, they feel numb from the waist down, and in some instances may still need help moving around, okay? Great example of this idea. Another good example is exercise. In fact, you may remember from our prior lecture on biology in the mind, when athletes get hurt on the playing field, they may not realize the true extent of their injury in that moment because all of that physical activity and adrenaline is increasing endorphins in their brain, which is numbing their pain signals. In fact, it may not be until they go back to the locker room that they realize the true extent of their injury, when all the adrenaline's coming down, they're not engaging in physical activity, and so forth. But perhaps the single-handedly best example of this idea that pain is psychological are people who experience phantom limb syndrome. People who report feeling a sensation in a part of their body that literally does not exist, okay? And the reason this happens is that for people who've recently had an amputation, their mind still contains a mental map of their whole body, where sometimes their sensory systems will misfire and lead them to feel a sensation in a part of their body that literally does not exist, which is wild to think about. And if that doesn't convince you that pain is more of a psychological experience than it is a physical one, I'm not quite sure what will. But that is probably the best example of that idea. Any questions on that? Any insights or comments or applications? Well, hopefully at least this point, we can kind of come full circle. And that riddle that I gave you at the very beginning of class on Tuesday, that if a tree falls in the woods and nobody's around to hear it, it doesn't make a sound, right? Because remember, hearing sound is more of a psychological process. It's not happening out there in the world like you think it is. It's happening in your mind. So if that active perceiver is not present, when that tree falls in the woods and nobody's around to hear it, all that's emitting are sound waves, but sound waves don't have any essential psychological properties of sound to them whatsoever. Okay, so we've kind of come full circle now in the class, and hopefully that makes a little bit more sense now. Okay. Well, before we completely leave pain, I did want to talk about one last important theory of pain, social pain theory. And according to social pain theory, the brain neurologically processes social pain as if it were physical pain. Okay, the brain neurologically processes social pain as if it were physical pain. Now, we know the causes of physical pain, right? So cutting your finger with a knife, breaking your arm, stubbing your toe. But what are the causes of social pain? Well, could come in the form of being rejected, being ostracized, being bullied, going through a bad breakup, and so forth. And with this in mind, we see in neuropsych studies that the same areas of the brain that activate for the causes of social pain also activate for the causes of physical pain, implying that rejection actually hurts. And that reinforces a lot of common stereotypes that people have when they're trying to communicate the experience of maybe going through a breakup, right? Maybe they'll say things like, man, that breakup felt like a slap in the face. Or man, that rejection felt like a stab in the back. Or even more commonly, I have a broken heart. Now, your heart isn't actually the thing that's weeping. It's your mind. But it is a testament to this idea that for many people, the experience of social pain feels as bad as if it was real physical pain, which is fascinating. And with that in mind, we see that the same kinds of effects that we see for social pain also mirror the kinds of effects that we see for physical pain. Okay? To give you one example, consider that we find that for people who just went through a bad breakup, they're a little bit more aggressive, especially to the person that they just broke up with. And to explain that a little bit better, let me first talk about what's going on the physical end of the spectrum, and then we'll work our way to the social end of the spectrum. So on the physical end of the spectrum, if somebody comes up to me and punches me in the mouth, on the spectrum of fight or flight, if I'm more on the spectrum of fight, I may be inclined to punch them back. Well, to the extent to which social pain is being processed as if it was physical pain, my mind is interpreting that bad breakup as if I was just punched in the mouth or slapped in the face or stabbed in the back. And if on the spectrum of fight or flight, I'm more on the spectrum of fight, I may be inclined to get even with them in some way, shape, or form. Maybe I insult them. I spread rumors about my ex. I gossip about my ex, or maybe even worse, who knows? But that's the idea. The effects of social pain mirror the effects of physical pain. Relatedly, we also find that for people who just went through a bad breakup, also go emotionally numb immediately after that breakup. Now, this probably flies in the face of a lot of common intuition that's telling you, hold on a second. I would think that for someone who just went through a really bad breakup, they'd be feeling a whirlwind of negative emotions. But that's not what we see. We find that for people who just went through a breakup, not talking about days later or weeks later, I'm talking about it just happened, they report a whole lot of nothingness. In fact, for those of you that have ever been there for somebody who went through a bad breakup and you ask them, hey, are you going to be okay? They oftentimes very confidently will come back to you and say, yeah, I'm going to be okay. I didn't need him or her anyway. Why is that happening? Well, let's explain this on the physical end of the spectrum, and then we'll work our way to the social end of the spectrum. So on the physical end of the spectrum, remember the athlete that gets hurt on the playing field, right? Because they're engaging in a lot of physical activity, when they get hurt on that playing field, they may not realize the true extent of their injury in that moment because endorphins are being released in their brain to help reduce their pain, help them cope, carry on, and keep moving. In the same vein, for the person who just been rejected, to the extent to which social pain is being processed as if it was physical pain, our mind is interpreting that breakup as if it was severe physical pain. So as a consequence, endorphins release in our brain, which numb the emotional pain signals associated with social pain. But in the same way that the athlete goes back to the locker room and then realizes the true extent of their injury, the person who just went through a breakup days later, weeks later, then begins to feel really bad. That's when they start going through the whirlwind of negative emotions, the depression, the anxiety, the low self-esteem, the worthlessness. I'm going to be alone forever. That's when they're calling you at 2 a.m. and they're telling you, I was wrong. I need help. And that's what we see. Any thoughts or insights or questions or comments on that? Are any of these experiences relatable to you or somebody that you know? Am I talking out my ass here? Has anyone ever experienced anything like this or no? I'm just curious.
Yes.
A little bit?
Well, when you break up with somebody and you're with them for a long time, you have those emotions. You're angry, but eventually you get over it.
Eventually, right? And what you're pointing out there goes back to a concept we talked about on Tuesday, sensory adaptation. That eventually, as time goes by, it starts feeling better. We start habituating. Right? This is closer to this idea that time heals all wounds to some extent. Any other thoughts on this? Okay. Well, if it is true that social pain is being processed as if it is physical pain, well, then perhaps if we treat the symptoms of physical pain, we can also treat some of the symptoms of social pain, right? And it turns out we do have some really remarkable evidence that Tylenol can actually reduce people's social pain, which is wild to think about. But the implications of this study are not necessarily that if you just went through a breakup or a bad rejection, that you should be popping Tylenol to feel better. Not the implications of this. In fact, if you go back to that study, you'll find that the effect sizes are actually pretty small. So the implications of this finding are more theoretical, right? It's providing us with some interesting insight into how your mind works, right? That we process social pain as if it was physical pain. So if you treat physical pain symptoms to some extent, you can also treat social pain symptoms, which is pretty cool. Okay. Any questions before we move forward? Okay. So up to this point in class, we've been spending a lot of time talking about how we sense and perceive the world in isolation of our other senses. Right? So how we see in isolation of how we hear, and how we hear in isolation of how we smell, and how we smell in isolation of how we touch and feel pain. But the reality is that when we're experiencing our world, our senses are all active at once, simultaneously, and they're interacting with one another in concert. Kind of like if you go to a concert or an orchestra, not one single instrument makes that concert. Rather, it's the collection of those instruments that brings the marvelous musical experiences that we hear when we go to a concert. Same thing with our sensory experiences. It's the collection of our sensory experiences interacting together that gives us the marvelous experience of the world that we experience on an everyday basis. So I did want to speak at least briefly about how our senses interact in very complex ways. And by no means is this very short illustration going to do this topic justice, but I want to at least give you some ideas. So as one of the findings you've probably heard of before even coming to this class, right, we know that for people who are blind, their hearing ability actually increases, right? So it's kind of a way in how our sensory systems are flexible and they're adaptable, where if we lose one sense, nature will increase our sensory experiences for hearing in this case to help us continue to interact and navigate our world in some seemingly effective way. Okay. Relatedly, we also see that flavor is a product of smell, taste, texture, and as I'll speak about very shortly here, price. Okay, so it's the reason why when you're tasting something, right, the flavor that you experience is also a product of how you smell. So if you hold your nose, or maybe if you have a cold, it tastes a little bit different, right? It's the same reason why that some people will say, you know, I really like the taste of that food, but I can't stand the texture, because the texture changes the overall experience for you, maybe even to the point where you just don't want to go near it at all. In fact, we also know that price can actually play a role too. And I have a short YouTube video here that we're not going to watch today in class with the short amount of time we have, but I will definitely check it out. But to at least give you a brief summary of what that video was about, and we have some actual experimental evidence to support this, where if you have people try one of two cakes, right, and both cakes are exactly the same, there's no difference between them, but you put a high price tag on one cake and a low price tag on the other cake, people will say that the high price tag cake is better and tastes better than the lower price cake, right? Suggesting that our expectations going into that tasting session can have downstream consequences and bias the experience we have with that food, which is really wild to think about. Okay, it's the same thing with wine. There's actually been some studies with wine that we've done where if you take off the price tag of wines, there are instances where people will say actually that the cheap bottom shelf wine actually tastes just as good as the upper shelf wine, right? So it might be something about putting the higher price tag on wine that actually makes it taste better for some people because it has that prior price tag, which is really curious to think about. And perhaps more recently and timely, and I'm going to talk about why this is timely in a second here, we also see something known as the McGurk effect, where actually I'm going to have you guys, I'm almost positive you've seen this because it's been circulating on social media. Have you guys seen this? This green needle brainstorm kind of thing on Twitter and TikTok?
Yeah, I've seen that before.
You've seen that here. I'll link it in the chat here for people who haven't seen it. And go take a look at this now. Here, it's coming in the chat. I'll turn off my mic so you can hear it. Okay, hopefully everyone had enough time to see that, hear that as well. So it is a very curious experience, right? Because you only hear the word that you're reading. And this goes back to what is known as the McGurk effect, where the sound is somewhat ambiguous. And when the sound is a little bit ambiguous, visual information takes precedent over auditory information, which is why you only end up hearing what you see as opposed to just what you're hearing. Right? And that's generally how that happens. It's called the McGurk effects. And the original demonstration is actually in the second YouTube link here. Check it out in your spare time if you're interested in these kinds of effects. But it's, again, a testament to even more examples of how our senses can interact in complex ways. And in this case, what we see takes precedent over what we hear. Okay? Any questions on anything we've gone over today? Any questions at all? Okay, well, that concludes our topic on sensation and perception. As always, feel free to reach out to me over email or office hours. I'm here to help you guys succeed. In our next class, we're going to begin our topic on learning. Have a great day, everybody.
Thank you, Professor.
Thank you, Professor.
Thank you, Professor.
Have a
Have a
good
good one.
day.
Thank you, everybody.